Okay. This talk could also be called how to build a carbon efficient website, because that's kind of what I'm trying to get at here. To give you the quick why, in case anybody's wondering, the internet today is responsible for 3.7% of the global carbon emissions total. And if you see in the link, you can actually see that this quote is from 2020, so it's already worse than that. And we're expecting these numbers to double between now and 2025. If you saw the subtitle on the last slide, that is actually the same as the flight industry. So all the combined flights of the world emits as much carbon as all of our data centers do for running the internet. That's pretty crazy, right? So that also kind of brings the why to the table. We're doing so much about making flying green and all of that stuff, but let's talk about, stuff that we as developers can influence. See if we can make the web a little bit greener. So it's not simple. A lot of what I'll tell you today is basically things to consider or trade-offs where one might be better than the other in one scenario, and it might be the other way around in other scenarios. I'm not trying to say that it's simple, but I'll try to make it simpler at least. Try to explain a little bit of how stuff works together. So let's start out by looking at what actually happens carbon-wise, you could say, but what actually happens when you go to visit a website. So I know that you're all front-end developer-ish. So at least you know kind of, I think most of you know how the web works. But I think I'll just briefly go through 15 steps or 17 steps of what it actually takes to build a website or to put a website on your screen. So typically somebody starts by typing in a URL or clicking a link. Then we look, first the browser looks in the service worker cache, and if there's no hit, it looks in the HTTP cache. And already here you see the spoiler that if there is a match already, then we can actually skip to the very end of this and save all of the work that goes on. Then if there's still no response, we start making a request. And the first thing we do here is again look in the cache. Do we already know where this server is? And if we don't, then we'll resolve the DNS. So this is kind of what maps a domain name to an IP address. So there's of course a server that actually serves up google.com. So if you type in google.com in your browser, we need to find a map of what IP is that, and that's what we call DNS. So that means now we look up where's the server located. Then we actually send the request to the new server, and the server starts working. So all the light blue stuff here is stuff that happens on the server. The dark blue stuff is stuff that happens, traffic-wise. Again, there's probably a layer of caching involved where if the server has already processed this kind of request before, it knows what to give you. But if not, it's going to start creating a response for you. Then it typically hands the request over to a web server somewhere that runs the application code. So this is where all the code that you've written that runs on the server actually runs. So this is your CMS or your Node.js or whatever. This is where all of your code happens on the server. Typically, and again, there's some caching involved here because a lot of times you need to then look into a database or look into some files or actually make a request to a third-party service or something like that, and all of that is slow, so we should try to cache that if we can. Then the server responds and the request comes back. Then on the browser, or on the client, in the browser, on your phone or whatever, we start looking at what is this thing that we've gotten. Then we discover what other things do we need to make this website look, to make this website, something that you can actually see. And that means typically there's some JavaScript files and CSS files and images and stuff. And all of that gets into a prioritized queue, and then we start doing all of this again. So that means all the way from the top, all the way down here, happens for everything that we need to make your website load. This is pretty significant. In average, there's 70 additional requests needed to make the average website today. So this happens 70 times for every page that you see on your website. Then we actually start running the code. There might be some headers that we start looking into. What's the request that came in? Is this a redirect? Then we should actually go do something else entirely. And then we figure out what elements do we have, where should they be, and eventually we draw them to the screen. So this is kind of a high-level look into what actually happens when you go visit a website today. Then there's a little bit of, then there's probably some user events that we need to take into account when somebody clicks a button. It might, put something in your cart or do something like that. So there's some responding to user events as well. All right. As I said, this happens in average 70 times for a website to render. And the request by count is distributed kind of like this. So most of them are images, but there's also quite a lot of them that are JavaScript files. So we'll look a lot about how do we optimize those two. That's a whole lot of stuff that goes on just to put pixels on a screen. And ideally, people would just not use websites, but of course that's not going to happen, right? Like the web is here to stay, and I think we all appreciate that because that's how we make our money. And I mean, it's probably also better that we use the web instead of actually taking your car and driving 200 miles to pick up something or to read something in a book that you could just find online, right? If you do run a business that is on the internet, maybe you should consider compensating for the carbon that you actually put into the air. At Umbraco, we use a service for this that's called ecology.com. This is actually a screenshot from our ecology.com page where you can see all the trees that we've planted, all the windmills that we've helped build and stuff. And this is really, really cool. And the reason why I bring it up to you is that the ecology website has a really nice API. So you can actually integrate this automatically into your build pipelines so that anytime you run a build, you also plant a tree to kind of make up for the carbon that your build actually probably produces. If you're a small-time shop, it's probably not worth looking into. But if you're a big company like Selling or other big companies, it might be something you should look into because there is significant power needed to build a website. All right. So this talk, we will look at the carbon emissions that come through energy consumption for the operations, for the transfer, and for the usage of your website. So that means, I know there's lots of other sustainability facts, but we're not going to talk about how your servers are made and where the minerals are from and who's digging them up of the ground and all of that stuff. We're not going to go into that. We're just going to look at energy consumption and the carbon that comes from that. All right. The cool thing about this is that most of the time, this actually also aligns with other business goals that you have because typically the equation looks like this, that better performance equals less carbon. And typically, better performance also equals higher conversion rates or happier users or whatever your metrics are. So a lot of the times these actually align pretty well. So let's look at how the carbon or where it actually comes from. 20% of it is produced or is used. 20% of the energy is used on the actual servers that does some work and ends up sending a file. 20% of it is used on the actual transfer between your device and all the way to the server wherever that is and back. And 60% of it is actually on the device itself. So there's a lot of stuff where we may micro-optimize something on the server and it might make a difference. But if you can do something that actually helps the stuff that goes on your device, that might be a better way to spend your time. But let's start on the server. Let's see what we can do here. So in this talk, I'm going to give you like 25, 30 things you should think about. And we only have like 25 minutes left. So you have, in average, 45 seconds to learn each. So I'll go through them pretty quickly. And the point is not that you remember all of them, but the point is that you see there's easy wins you can take. There's some that are harder that may make a bigger difference. It's something we can all do at least some part of. And all the slides are available afterwards. I'll put up a QR code so you can download it and find them afterwards so you can dig into what they actually mean for your website. But let's start on the server. As I said, process only once is a pretty good place to start. A lot of us today are doing static websites, and some of us may be pre-rendering all of our stuff in some Next or Noxt or whatever application that runs every time you publish in your CMS or in your commerce engine or wherever. And it's pretty good that it's a pretty good advice to think about, can we make sure that this only happens once? With pre-processing, we go straight into number 2. there's a pretty big risk that you end up doing work a lot of times for content that no one will ever see. If you pre-render a website that has 10,000, 100,000 nodes, and you do that 10 times a day, there's a pretty good chance, pretty high chance, that a lot of pages will be pre-rendered but never seen before they're pre-rendered again. If that's your situation, maybe you can do the rendering on demand instead and then cache them so that only the first request to every page is slightly slower, but you save a lot of extra processing. Might be something worth looking into. Of course, use a content delivery network. This is probably a best practice that a lot of you are doing already, putting your servers or putting your files close to the user. A lot of the times, the CDN actually also works as a distributed cache, so that all the processing that happens in your CMS or in your Next or whatever can actually be handled all the way on the CDN. And just by using regular HTTP headers and stuff, you can control exactly how the CDN is allowed to, or for how long it's allowed to store your files there. Yeah, be aware if you're doing this that sessions, cookies, headers and stuff may influence how the CDN is actually allowed to store things. So test it out. All of the CDNs out there, you can see in the headers whether they're actually serving stuff from the CDN or they're going back to the master. So make sure that you're actually doing what you're trying to do. Then think sustainability into your architecture. Architecture is a pretty big thing. There's so much hype going on today. Should you go headless? Should you not? Should you have a dedicated backend for front end? Should you have a classic suite? Should you go fully composable? You should do microservices and serverless and all of these things. And I'm not here to tell you which one is better, because that depends on a million things. But take into account why you're doing things and what's the best approach. So if you're doing headless just because it's cool and all the cool kids are doing it, you typically just end up with 3 servers to do the same thing that one server would typically do for you. And that means 3 times as much carbon. If you're running your services as microservices, maybe they will actually end up taking a lot of time being always available. Maybe a lot of them could be functions instead, so that they only turn on when there's actually anybody using them. Lots of small micro optimizations you can build into your architecture, and if you think about it when you build it, it's no extra effort, but it's probably hard to reintroduce this after the fact. All right. Also, some of the things that we often forget: do we really need a full duplication of our production environment for staging? Not necessarily. Maybe you do, but not necessarily. And if you do they really need to run 24 hours a day? Do they need to run in the holiday season? Do they need to run in the weekends? Turning them off may make a pretty big difference as well. And it'll probably save you cost as well. And of course, choose all the vendors that you use wisely. So if you depend on Vercel or Netlify or Salesforce or Commerce Cloud or whatever dependencies you have, think about these as individual things in your architecture, and if they're not something that you're in control of, then demand that they are. Ask them, what are you doing about sustainability? How much is actually emitted from the usage of your service? These are questions that pretty much all of the big vendors can answer today, and that you should take into account when you're planning out how your architecture of your site should look. And a lot of it is also about the technologies that they're on. And this is the only time I'll mention Umbraco, just to brag a little bit. We switched from old .NET runtime or .NET framework to .NET Core, and we saw at least 50% extra performance across everything that we do in the CMS. And that's pretty significant, right? And I'm not trying to tell you, use Umbraco instead of something else. You probably should. But that's not the point of this. The point is that you should consider all the vendors in your architecture and think about, what are they doing? Are they on legacy stuff? Can they run as functions instead of services? What can be done? All right. Yes. So, sorry. I'll go one back. Maybe. Choose the right cloud. All of the clouds today are basically carbon neutral or carbon net neutral, meaning that whenever they can, they run on green energy, and when they can't, they will run on classic black energy, and then they will compensate somehow by planting trees or building windmills or something in that regards. But a part of this is also choosing the right region for your stuff. A lot of times we pick regions only based on what is closest to us or what is closest to our user or what is the cheapest. But there's actually lots of things that you should think about here. Think about closeness might actually not mean shorter traffic. These are all the C cables that connects the internet today. So let's see you have all your users are on that small island out of Africa. If you position, it's actually a Portuguese island, and if you position your data center in Portugal, there's no connection over there. So even though it might be closer physically, if there's no cable, then it's not really closer in actual kilometers that the data has to travel. Let's also talk shortly about gross versus net carbon. I said before that all the major cloud players today are carbon net neutral, and that means that they compensate. But that still means that some of the time they actually emit carbon. Compensating is fine. I'm not going to go into that whole rabbit hole. But think about this when you choose your region. Maybe don't choose only for closeness, but choose for efficiency. So this was a story from a US partner that went from the Las Vegas data center that was 19% green to an Oregon data center that was 90% green. And this means that 60% of the time was green instead of black. And that's a pretty significant difference when you're running servers. And I mean, if you know US geography, you know that Vegas and Oregon is pretty close, and I bet that no user would ever notice that there may be half a millisecond longer to get to your website. Take this into account. This actually also saved the customer some money because the Oregon data center is cheaper. But think about that. And the same thing when you're doing non-time sensitive processing on the server. Think about when is the best time to do this. So as engineers, most of us are, has grown up with thinking processing that we do off time, it needs to happen in the middle of the night. But if your server runs on solar, the middle of the night is probably the worst time you could do it. Then you should do it in the middle of the day where the sun shines, right? To take this into consideration when you're doing your planning, see what actually makes sense for you. All right, so this was the server part. Now let's talk about the device part. So the power consumption on your device is primarily these three things, and they're in order of how much power they use. So the antenna is the worst thing on your phone in terms of power. So whenever we can, if we can save files from being transferred, if we can turn the antenna all the way off, we are doing a lot better. That's the biggest difference you can make. The next one is the screen. The screen takes lots of power, especially these modern screens that can run extremely bright so that you can see them out in the sun. And that's really, really nice as a user, but it's terrible for energy consumption, right? And the last one is the CPU. There's of course all the other components, but they're pretty negligible in this in this comparison. So these are the three things, and we'll try to think about this. First, think about sustainability here as well. So the architecture that actually happens on your front end, on the device, think about that in terms of sustainability as well. We used to talk a lot about single-page apps versus classic multi-page apps. And I mean, the difference is pretty clear. If you have websites that only have, where the average user only visits 1 or 2 pages, the classic multi-page app is probably better because it gives you lower overall traffic. If you have a website with lots of concurrent visits, then the single-page app is probably better. Even though the upfront payload is higher, then all the subsequent requests are smaller. All right. But when it comes to the average website today, we're looking at 2.3 megabytes of stuff. And that's the median or the 50th percentile. If you look at the top 10 or the 90th percentile, we're actually at 9 megabytes. Let me just go back to the slide that was on. we're actually at around 9 megabytes. So it's almost 5 times as much data for the 10 worst percent that it is for the average. And on mobile, it is even worse. We've seen an almost 600% increase in mobile page weight over the last 10 years. And I think that shows you that we were actually able to make pretty great websites at a sixth of the traffic that we do today. But back then we needed to because phones were slow, network connections were slow, but today they're fast, and then we just become lazy. So think about this. This is not necessarily super hard. Just think about mobile as a separate thing and think about it as something you should optimize for. So I showed you the graph before where we were counting requests. Here we're doing the same thing, but we're counting bytes that are transferred. And here you see even more that images is the worst thing for your website. Of course, it's also a pretty important thing, right? That's a lot of times that's what people are coming for. It's hard to imagine Flickr or Instagram without images, but it is a pretty significant, part of all the websites that run out there today. So that's what we should be looking at optimizing as well. Of course, the greenest request is the one that's never made. I started out by talking about caching. We'll come back to that in just a second. But one of the patterns that we're seeing is that we want to make a great user experience for our users. And that means let's put stuff, when they start putting their mouse close to a link, then we'll preload all the stuff that we actually need so that we can, so that the next page load can be super fast. And that's really something you should be aware of, right? You can really overfetch so much that's never going to be needed. So if you load something to give a better user experience, but you end up loading twice as much as you needed, you're doing a terrible job from a sustainability standpoint. I don't know, 5-6 years ago or something like that, HTTP 2 came out, and everybody was super excited about the push feature in here. So if you don't know, it's a feature where as soon as the first request hits the server can say, hey, I know you're also going to need all of this, and just send that down to the user. It's going to push it down. That's why it's called push. So it's not push messages, but it's, yeah. So the server is pushing down assets, resources, images, JavaScript files, all of that stuff as soon as the first request comes in, because it's trying to be smart. But this is the worst thing when it comes to overfetching, right? Because this means that no matter if you already have it in your cache, or no matter if you're really going to need it, if the server somehow thinks that you need it, then you'll pay for it. You'll have all the traffic for those files. So this is extremely dangerous, and HTTP 2 push is something that you should almost certainly avoid. If you have a use case where you really need this, then of course, then you just really need to be very cautious about this. All right, redirects are extra traffic as well. So you saw that basically the last step, or almost the last step, was looking at the headers and then trying to figure out, oh, is this a redirect? Then I have to do everything all over again. And Google told us, in the last 10 years, Google has told us, if you move anything, then you put a redirect in, and then we will still be able to, you can keep your page rank and everything will be happy. What they don't really talk about too much, but I really think they should, is the fact that by a simple HTML tag, you can actually tell Google that this is where the original URL for this page is, and then you can just serve the content that they're actually using instead of serving a redirect that serves no purpose at all. So, if you go to a page and your CMS needs to render some content, instead of the CMS saying, it's actually over here, go ask me again, then the CMS could just, give you the data that you want and then tell you, by the way, it's actually over there. So that's the difference, and that's, it saves you an extra request. You should do this for of course, pages that move, for your host names, when you have three different domains for your website, make sure that they all work. And instead of redirecting to each other, just make a canonical or something so that Google will know that this is the right URL. And nobody's going to care if they see your website without W's or with W's. That's not going to hurt your brand. Don't force a redirect on people just to do that. Where you may force a redirect is, of course, when it comes from HTTP to HTTPS. You don't want to sacrifice security to save a simple redirect. But with HTTPS, there's actually a different feature that's called HSTS, which is where, as a host name or for your domain, you can actually opt in to telling the browsers this host name only ever works with HTTPS. And that means that the browser won't make the request to the domain without HTTPS just to be redirected. So you should look into this. It's a little bit more complicated to set up, but I mean, you can save the first redirect and everybody's happy and your website loads faster. You should think about minimizing the number of host names that your website has. This used to be a best practice because back in the days, the browser could only do 6 requests at a time to a given host name. So we would just come up with, then there was mydomain.com, and then we had, assets.mydomain.com and cdn.mydomain.com, and they all pointed to the same server. The only thing we did was just trick the browser into thinking that they were separate servers so we could have more parallelization going on. But this is a bad practice now. This means that you have to do all the DNS stuff again, and it also means there's some compression stuff that is less efficient. But I'm not going to go into that. That's not going to change the world. But minimize the number of host names when you can, and that also means think about whether tracking scripts, whether your fonts, all the stuff that typically think self-host these. There might be legal reasons why you can't. Some of the fonts are licenses to only be hosted from a separate location, and then of course you should honor the license. But if you can, technically there shouldn't be any reason why you shouldn't be able to self-host all of these external dependencies. One of the things that I've been seeing to try to save traffic is using WebSockets. WebSockets, I would say, qualifies as a double-edged sword. It can be extremely helpful. It can really cut something really nice for you, but there's also a big chance that you just end up cutting yourself. And I mean, the point is here, if you're doing something that is pretty data intensive and that needs to be real time, then WebSocket is a great fit. There's a payload, there's a pay cost, or there's a cost to get started. But after that, all of the requests are pretty small and well compressed. But if you don't need if you're only doing small things, or if you don't need them to be super fast, then just doing regular HTTP requests is probably a better thing from a sustainability standpoint. All right, I've already talked about on-device caching. The HTTP cache is something that we more or less take for granted. It's something that basically comes in all the systems that you use. They set some kind of header that says you can only keep this version for so and so long. You should think about these numbers so you don't, invalidate your cache for no reason. But the problem with HTTP cache is that it's pretty unreliable. Facebook did some tests because they have, a lot of users, where they were looking at how much of the stuff on our website should actually be cached with HTTP cache, and how many times is the browser actually making the request anyway. So the cache doesn't work. And it turns out that HTTP cache only works about 50% of the time. So that's pretty disappointing, right? Because you don't want to, ship all the data twice just because your browser is stupid. HTTP caching is a pretty good thing, and as I said, it's typically the way you configure your CDN anyway. So do it right, but maybe you shouldn't rely on that totally. What you can rely on is a service worker. A service worker is a new mechanism where you can actually write your own caching. The cool thing is that this is persistent. You know that it works. You know that it's there, and it never goes away. The problem is yourself. That's a good thing, but that's actually also the bad thing, right? You need to control everything yourself. All of the caching algorithms for how data is cleaned up, and for how long it's stored, and for how long it's valid, and all of that stuff you need to do yourself. It's the powerful thing, kind of hard. So at this link, there's a Google tool called Workbox. Kind of a Node-ish API, or like an Express API to handle all your cache service workers. So that's a pretty good tool to make it easy with a cache that you can actually count on. All right. The next thing, now that we're talking about is of course to put lazy loading on everything. So if you don't know, loading lazy is an attribute that you can put on elements in your DOM, and that means that the browser won't load them before they're actually in the viewport, or at least getting close to the viewport. So you should do this for images, videos. You can actually do it even for iframes today. And that's pretty cool, and it's a great way to save data for all those images in your footer because they don't scroll to see your footer. Do this, do it wisely, but what you don't want to do is put it on everything. I know I said put it on everything, but don't put it on everything. Because this actually changes the priority queue of what order your resources are loaded in. So for that big beautiful hero image in the top of your page, if you have that, then don't mark that as lazy loading, because that's always going to be seen, and that just means that your website will load slower and your users won't be happy. From a sustainability standpoint, of course, do it, but probably from a user experience standpoint, think about the things that you know that people will always see, and don't put it on that. You can also do this with your code. Of course, a lot of the tools that we use today can automatically split your code into chunks and load them on demand. And there's actually even a cool project called Guess.js that looks at your Google Analytics data to try to predict what's the next route that your users will go to, and then preload that for the user. Of course, I said before, preloading is dangerous. Do this only when you know that that's where the user goes, or if the chunks are really, really small. But it is something that's pretty cool, and it's always a lot better than just giving them the huge bundle with everything in it. All right, so that was talking about how can we do as few requests as possible. Then let's talk about how can we make the requests smaller, because a pretty big is actually how much is moved over the wire. So a good place where you can make a pretty significant difference is to look at custom fonts. So a lot of the times, some graphic person somewhere has chosen that you need to use this beautiful font that has, embodies your brand and everything is perfect, and a lot of the fonts like that come with lots of characters that no one ever needs. So this is the which is which is something that actually a lot of people use. But this is just to show you that there's actually 5 extra A's. And I bet you that in a Danish context, none of these would ever be used. Maybe if you're in a Swedish or German context, maybe the A with the 2 dots on it may be used. But the point is, you know your audience. Take away all the characters that they're never going to use. And if you really want to play it safe, there's actually ways in CSS where you can say, these are the characters in this font, and then if some editor somewhere should put in a weird version of the A, then you can tell CSS to go look in that full font that has all the characters in it when it's actually needed. So you only load the small one to get started, and then you have the big one if people actually need it. Doing this on the inter font takes it from 95 kilobytes to 16. So it's an 83% saving for removing stuff that no one ever uses. And fonts are actually a pretty big deal. If we said that the average website is 2.3 megabytes and a font like this is 100K, that's 5% of your budget for your website. Of course, minifying your text assets, this is something that pipeline should do. Don't do this by hand. In all the indentation to make our code, machines don't need that. Don't ship it to the browser. Don't ship it down the wire. I know we've been saying this for 15 years, but when we look at the data, there's still 25% of websites that doesn't do this. So if that's you, start doing it as soon as you can. This goes for anything that's text-based, so your HTML document should do it, your JavaScript files, your CSS files, if you use SVGs, all of the stuff that's text, you should be minifying. And talking about further improvements on text, you should absolutely be compressing them. This is something that your web server typically automatically does and your browser automatically supports. We've been saying use gzip forever. There's now actually a newer thing called Brotli that's a lot more efficient than gzip is, and it's supported by 96% of the browsers. You can make a fallback to gzip if you need to. This is something that saves a lot of data. This is also something we've been saying for a while, and also here we see about 25% of users not doing this. This is a super easy win. Takes all of your text-based files down to 1/3 of the size in average. Do this. When you're doing images, think about scaling them. How big do you really need that hero image? Do you really need it to be double-sized for your mobile audience? Could you maybe, if you know an image is going to be used twice, maybe use the exact same size so you can use the exact same file instead of doing the same image in 2 different versions. Think about the scale, and also think about the compression of your images. So a lot of us thinks that a JPEG is a JPEG is a JPEG, a PNG is a PNG is a PNG, but it's not. There's so much to play with. There's so many settings to compressing images that makes a huge difference. So if you don't know, there's a website called squish.app. Upload, and then you can play around with all the settings, and you can see how big of a difference you can make. So you can see the original versus the new one. And I bet you that in most cases you're able to save anywhere from 50 to 80% of the weight without change. Again, this is probably not something you want to do for each image individually. Something where you want to come up with the settings that works for your scenario and then put that on your web server, so this is a thing that happens automatically. But there's a lot of saving. You see here in this nice picture of some animal, I don't know what, we saved 70% to a JPEG, decent settings on it. And I kid you not, no one knows the difference between the 2 images. GIFs are fun, of course, but GIFs are terrible. They compress terribly. Code this as a video instead. So that stupid video, the GIF I showed you before is actually a video. And when I made it from a GIF into a video, I saved 75% of the data for the exact same thing. No one's going to change, no any changes, because there is no changes. It's the same thing. It's just a different format. So don't ever use something that's called a GIF, whether it's a GIF or a GIF. All right, one thing that's close to my heart: autoplay. Don't autoplay anything. As a user, I hate it when stuff starts playing on my device without. I wish there was. My browser won't ever allow anything to play without me pressing a button, but there's not. It is terrible for user experience, but of course it's also pretty wasteful in terms of traffic. There's so much data, especially if it's video, there's so much data being transferred that no one really likes, or at least not everybody likes. So I thought I'd try to actually quantify that. So 20-second video on YouTube. I embed it on my screen, on my website, and the regular embed with autoplay on is lots of data. If I turn off the autoplay, it goes down to 50 kilobytes. That's a pretty significant change, right? But 250 kilobytes is still pretty much like that's 10% of your budget if your budget is 2.3 megabytes, right? What you could do is, put in an image, and when you click, that's where you actually do, and that will, save you a lot more data. This 25 kilobyte here is even including the actual image. So the code to do this is 3 lines of JavaScript, right? More often than not, this is a good approach. If you want to have something that kind of mimics an autoplaying video, maybe make a small that has 3 frames a second or 5 frames a second in a video, and use that, and then when you click, do the same thing. Maybe there's a UX trade-off, maybe 50 kilobytes instead of the 250. So I thought it was kind of fun to see the difference you can do in terms of kilobytes, but where it's actually interesting is to see the difference that makes in a CO2 world. So still, if 1 in 10 watches, I don't even think that's a high number. I think it might be less that actually clicks your video. If 1 in 10 still watches, then you end up saving 1.67 grams of CO2 per visit to your website. I was, as I said to some of you guys in Stockholm doing this talk yesterday, and that means that we only need about 40,000 visits to your website to actually save my flight to Stockholm. I think that's pretty cool, and I think that kind of shows what a difference we can make as web developers to something that actually translates to something that's tangible and that's real, and where we can see, and saving that what equates to that. I think that's pretty. And 41,000 visits is actually not that much. Some of you may be working on websites that has 40,000 visits a day. I think most of us probably have 40,000 visits a year on our website, but if this is something you can enable for free, why not do it? All right, this takes us to the screen, and a pretty big thing here. I said before that 60%, and the screen is the second biggest thing on your device that takes power. A huge thing is dark mode. All of your modern OLED phones, they actually take up less energy when they're showing dark pixels than when they're showing light pixels. So much that you can actually, on a bright sunny day, you can actually save up to 47% of the power by having a of your website instead of a light mode. If you don't have a dark mode, building one. If you already have one, consider making it the default. As you know, there's CSS media queries where you can say use the light one, or if the user has opted into light, then use this one. If the user has opted into dark, then use this one. And of course, that kind of makes sense. But the question here is, what do you do when the user has no choice? And a lot of the times we default to the white mode, but maybe defaulting to the dark mode would be a pretty easy way to save to make a pretty significant save. And this is a good example of one of the places where, just as you think you know it, then it turns out that if your user is on an LCD screen, it's actually the other way around. And that's terrible, right? But at least you should consider maybe doing dark mode for mobile devices, because most of them don't use LCD screens anymore. But just know that, have that into consideration when you choose your strategy here. Of course, you can also think about the processor on the phone. The greenest processing is, of course, also the ones that never happens. On the phone, what can we do only once instead of twice or multiple times? And one of the things that we can fix, that we can do pretty easily, is efficient animations. Animations that run on the CPU takes a lot of power. If you've been playing with this, you know that your phone, when you do terrible animations, not only do they run bad, but your phone becomes warm, and that's a pretty good sign that you're doing something wrong. So I'm not going to take you through how to build efficient animations. I'm just going to say, to paint a pixel, there's a whole different things that happens. We need to figure out all the elements, put them out. But what we want to do to make efficient animations is to make sure that the only thing that we're changing is the actual paint. We do this by animating primarily the translate and opacity things in CSS, but go YouTube that. There's a million videos that shows you how to do that, so I'm not going to go into that. All right, we're about done. Putting things into perspective a little bit. Dark mode is huge. Autoplay off, please. And then maybe think about, do I really need that for anything that you put on, anything new that your boss tells you to put on your page? Tell him, do we really need this new tracking script? Do we really need this new split testing tool? Do we really need this, cookie banner? You can make a difference in pretty small ways that actually makes a pretty big difference. Of course, if you are running an e-commerce platform, then before you start looking into removing a simple tracking script, it may be more important to think about what's your return policy and how much do we, or what freight offerings do we have and all of that stuff. But again, that's not the point of this talk. But you can actually make a difference by saving all the JavaScript that runs on your device, because that equates equally to CPU runtime. All right. So of course you're asking yourself, how am I doing here? How's your website actually performing? How green is your website? I think most of you will know the Chrome DevTools, will know the Lighthouse tests in there. There's actually a plugin to Lighthouse that's called the Sustainable Web plugin. You can find it on GitHub, or just Google it and you will find it. That gives you a score on your website from a sustainability. It's just like from the rest of the test in Lighthouse, use that size or whatever. Same kind of thing, but for sustainability. Good place to start. If you want to show something to your boss or make it there's a good website called websitecarbon.com where you can put in a URL, something like this. You're not doing well, or yes, it runs perfectly. And of course, we should all strive towards our websites being in the top 5% and being super fast and super green. And this is typically something that your management will understand. And what about my app? Should I really have an app? I know all of you here will just build websites, and that's typically the right thing. We talked about the single-page app versus multi-page app kind of difference. A big front to have smaller requests in the back. But think about this. You may save a little bit of data with an actual app instead of a website, but the average app size for your iPhone is 38 megabytes. So compare that to the 2 megabytes that your website loads, and from a sustainability standpoint, your website is going to win every time. All right, you can make a significant difference. You're not alone. If you want to learn more about this, there's a great website called climateaction.tech. There's a whole community in there. There's a Slack channel where there's lots of good discussions going on and where you can ask all your questions. And with that, I'll say let's be responsible, one website at a time. And here's my slides. We can take questions if you want. I'll probably say it depends to all of them. Yeah, go.
Have you looked into not using HTTPS for non-privacy sensitive pages compared to, like, have you looked into the compute?
Of course, there is some. There will be a little bit of compute in matter of back and forth with the encryption, right? But that is pretty negligible. But no, I haven't looked at it. I don't know how much data is actually, how much you could save.
Is Bitcoin mining part of those 3%?
I had someone ask me the exact same question yesterday. I don't know. Honestly, I don't know. The link with the 3.7% is from BBC. It's not. I don't think it's in the article, but I don't know. But it's from 2020, and I don't know how big Bitcoin mining was then. Lars?
What about managing dependencies?
There's a great tool for that, I hear. I mean, of course, when you're building your JavaScript dependencies, all of the stuff that goes into your bundle, you pay for that. That needs to be downloaded, and it needs to be executed on the browser, or on the client. Thankfully, most of the tools that we use today have some kind of tree shaking mechanism or something where it throws away the stuff that's not used if you're doing it right. But that is hard, and that's something you should look into. Absolutely.
You said something about customizing the fonts, but you also mentioned something about making use of CDNs so that you actually won't have to download fonts. In that sense, it will be better to
I'm glad you bring that up, because that is the most common misconception I get out there today. So back in the day, we used to say use a CDN because if everybody uses the same CDN for jQuery, then we don't need to download it more than once. But there's a lot of security in sharing resources. So across all of the browsers, they don't share any cache between different host names as origins. So if website A requests something from the CDN and website B requested from the exact same host name, domain, everything, the browser downloads it twice and keeps 2 copies. So there's no savings in using a CDN from that perspective.
So it's your own CDN, you mean? Use Cloudflare?
Yes, exactly. Yeah, so put a CDN in front of your own website. Cloudflare, there's lots of them. Cloudflare has a free plan that's actually pretty good. So if you're just running something that's relatively small and where you don't need WAF headers or something like that, then the Cloudflare free option is pretty great, and it makes your website run faster, and it makes it run super close to where your users are. We'll do Frank first.
Yes. What do you think about ads? How much do they account for when it comes to?
Do you really need ads? That's the question I would be asking. No, I mean, yeah. Typically, ads do all the wrong things. They do multiple host names. They do terrible animations. They do all the data that you don't need. They do all the wrong things. So from a sustainability standpoint, I would say avoid ads as the plague. But of course, sometimes for business reasons you need it, and that's where there's no one answer to that. So if that's what will pay for you to hire someone from Hack Your Future, then it's probably worth it. But yeah, if you only look at it from a sustainability standpoint, ads are typically horrible.
Yeah, on that font subset thing, I was thinking, I mean, it's kind of like depends on what you're running, right? Because if you're running like an e-commerce that's running like in 20, 50 markets, so then it really doesn't make sense to just send a subset because you have, I don't know, X number of languages that's going to be using the website, so it doesn't really make much sense.
Yes, but typically the website would then have multiple languages and then serve a different font file based on what language you're on, because the Danish language will always need AO, and the Swedish one will always need the one with the dots on top, and the British one will never use those. So I think from a lot of times you can do separate fonts based on what language you're in. And then one other thing to say about fonts that I didn't really mention is there's now actually a standard called flexible fonts, or what is it called?
Variable fonts.
Thank you. Variable fonts where you can actually, where you don't have to ship multiple versions of the same font to have a bold version and an italic version and all of that stuff, but where you send instructions to how to make them bold or how to make them something like that. So there's a lot of savings typically possible with variable fonts if your font has multiple, forms or like multiple versions that you need. But that's also a pretty good place to see, do I really need the font weight 400 and 600 and 800 of my font? Do I really need all 4 versions and in italic and in bold for all of the versions of 95 kilobytes a piece? You probably don't. Maybe you can think about only using regular and bold, or even have regular and then have it as a variable font so you can add bold in the browser. All right, that seems to be the last question. Thanks for listening. And Jakob, do we have any final words?
Yeah, sure, of course. Thank you so much, Filip. Awesome talk.